The cosmos, as we all know, is enormous. Because it is so energizing, there are many things we don't know about. Perhaps there is another life beyond that we are unaware of, or maybe there are other planets. There are so many things that we are unaware of. Recently, NASA citizen scientists just discovered a new planet. An exoplanet, to be precise. This new planet is enormous, more than 3 times the size of Jupiter. This new discovery is unique. TOI 2180b is the name of this massive planet. Do you want to know why this new discovery is unique? And do you want to know more about this planet? Keep watching to find out. A team of astronomers and citizen scientists discovered an uncovered planet the size of Jupiter in a faraway solar system, and they should see it again soon. At only 379 light-years distant, the planet TOI 2180b is rather close to us here on Earth. But what sets this world apart from the rest of the known big exoplanets is that it orbits its home star for 261 days, significantly longer than other gas giants identified outside of our solar system. This new planet, TOI 2180b, is an exoplanet. But what is an exoplanet? Exoplanets are planets that exist outside of our solar system. Thousands of them have been discovered in the last 2 decades, largely because to NASA's Kepler Space Telescope. These planets are available in a wide range of sizes and orbits. Some are massive planets orbiting their parent stars, some are cold, while others are rocky. NASA and other organizations are on the lookout for a planet the size of Earth that orbits a Sun-like star inside the habitable zone. The habitable zone is the distance from a star at which a planet's temperature allows for liquid water oceans, which are necessary for life on Earth. The habitable zone was first defined based on basic thermal equilibrium, but modern estimates take into account a variety of additional elements, including the greenhouse effect of a planet's atmosphere. The borders of a habitable zone become fuzzy as a result of this. Using data from NASA's Transiting Exoplanet Survey Satellite, or TESS, the team discovered the world. TESS finds exoplanets by detecting tiny, repetitive dips in a star's brightness caused by a planet blocking a small portion of the star's light when it transits, or passes between the spacecraft and the star. While the orbital period of TOI 2180b is unknown, astronomers believe TESS will observe the planet again in February. But what is TESS? The Transiting Exoplanet Survey Satellite, TESS, is a NASA spacecraft that looks for planets around Earth's brightest stars. The project will scan at least 200,000 stars for indications of exoplanets, ranging from Earth-sized rocky worlds to massive gas giants, during the course of its anticipated lifetime. In the first 2 years of TESS operations, scientists hope to locate 10,000 extraterrestrial worlds. TESS was supposed to last for 2 years, however NASA announced in July 2019 that the mission will be extended until 2022. TESS has confirmed a handful of planets and has hundreds of potential candidates to investigate in its database as of early 2019. NASA's TESS spacecraft looks at one part of the sky for a month before moving on to identify exoplanets that orbit stars other than our Sun. It searches for brightness dips caused by planets passing in front of stars. The rule of thumb, according to Dalba, is that we need to witness 3 dips or transits before we assume we've discovered a planet. A conference called the American Atomical Society's 239th meeting was held on January 13, 2022. Professors and scientists discussed the new finding. This latest finding is cool, according to Paul Dalba, a postdoctoral researcher at the University of California, Riverside, not just because of how distinctive the exoplanet is, but also because of the lower temperature produced by its longer period orbit around its parent star. There's a lot of science motivation behind studying long-orbit exoplanets. We can ask questions like, do short and long-orbit exoplanets form differently or evolve differently? How do they change over time? Dalba noted. TOI 2180b is similar in size to Jupiter. The planet, however, is about 3 times more massive, containing around 105 Earth masses of elements heavier than hydrogen and helium, according to a press statement from the University of New Mexico, where Discovery team member Diana Dragomir works. The planet's density variation might imply that it originated differently from Jupiter. Another anomaly is the planet's temperature, which is a pleasant 170 degrees Fahrenheit on average. Even though TOI 2180b is warmer than Jupiter and Saturn, it is still cold in comparison to several other massive exoplanets. Many of the gas giant exoplanets discovered so far are close-orbiting hot Jupiters, which are simpler to detect because they transit more frequently and exert a stronger gravitational pull on their host stars than planets orbiting farther away. In a NASA press release, Dalba said, "It's a nice stepping stone in between most giant exoplanets we've found, and then really cold Jupiter and Saturn. This temperature difference is unknown, but astronomers believe it may be investigated further using data from other observatories, such as NASA's recently built James Webb Space Telescope." A unique collaboration of astronomers and citizen scientists, including retired U.S. Navy Commander Tom Jacobs, produced this finding. Jacobs took part in Planet Hunters, a NASA-funded citizen science initiative that utilized data from NASA's now retired Kepler planet hunting satellite and was administered through the internet platform Zooniverse. In the same NASA release, Jacobs said, "Discovering and publishing TOI 2180b was a great group effort demonstrating that professional astronomers and seasoned citizen scientists can successfully work together. Through a cooperation known as the Visual Survey Group, a group of citizen scientists and astronomers studied test data together." On February 1, 2020, Jacobs noticed a plot showing starlight from TOI 2180 dimming by less than 0.5% and then returning to its previous brightness level over a 24-hour period, which could be explained by an orbiting planet that passes in front of the star from our point of view and is said to transit. Scientists can determine the size of the planet and its density by measuring the quantity of light that dims as it passes by. A transit, on the other hand, can only be observed if a star and its planet align with telescopes looking for it. A light curve is a graph that shows the progression of starlight through time. The Visual Survey Group notified two professional scientific colleagues, Paul Dalba of the University of California, Riverside, and Diana Dragomir, an assistant professor at the University of New Mexico, that this light curve would be of interest. Because other variables, such as sunspots, might cause stellar brightness changes, Jacobs requested confirmation from astronomers Dalba and Dragomir. TESS only detected a single dimming of the star, but observations by the Automated Planet Finder Telescope at Lick Observatory in California and the Keck Observatory in Hawaii provided further information to the researchers. The gravitational tug of the planet on its parent star was detected by these two observatories, allowing the scientists to determine its mass. However, the planet's orbit is still unknown. During August 2020, the team used telescopes at 14 locations across 3 continents to hunt for a transit once more. Regardless of the fact that the partnership provided 55 datasets in 11 days, no telescope was able to capture the transit. Despite the dearth of information, scientists were able to place a boundary on its orbital period, which NASA estimates to be 261 days. In comparison to many other known gas giants, this is a lengthy time. In our solar system, it takes normally 18 hours for a gas giant. TOI 2180b will also be studied further by scientists in the hopes of finding rings or moons, which are frequent among gas giants in our own solar system. The majority of large exoplanets identified have been located relatively close to their parent stars, where the planet's rings may be ripped away by the tremendous gravity. Because TOI 2810b is further away from its star, it may be a fun system to search for moons or rings, according to Dalba. So, planet TOI 2810b is one of NASA's most recent discoveries. TOI 2810b has previously been studied by scientists. However, there are several aspects of TOI 2810b that have yet to be uncovered. Scientists and astronomers are fascinated by the secrets that this planet holds. Are you looking forward to TOI 2810b? And are you excited to learn more about TOI 2810b's secrets? Let us know in the comments.